Will Feynman be useful in this integral? Let's see. And to use Feynman techniques, we use the most appropriate trick that we have been using for the logarithmic integral function. So over here, firstly, let me introduce that logarithm integral function. It's just integral from 0 to x of 1 by ln of t dt. And throughout all the past videos, we have just used the same technique, just a common technique to deal with such function. Yeah, where we had to use Feynman technique. Let me show you. So what we have been doing in most of the videos is just that we are trying to find integral from 0 to 1. Now everything except the li function, and we will write li function in different way. We will write li function as integral from let's say 0 to x e to the power minus ln t times a by ln t dt. Yes, and then dx. We will be define this as our required integral such that if I substitute a as 0, I of 0 will just be our answer because integral from 0 to x of 1 by ln t dt is just li of x. Yeah. So we are basically interested in I of 0. And now this integral, this new integral will be easier to solve because if we use the Feynman's technique, this will simplify. See that I dash of a will be integral from 0 to 1 log of p to the power minus 1, sorry, log to the power p minus 1 by x, and then this is integral from 0 to x, and then e to the power minus a ln t times minus ln t by ln t times dt dx. Yeah, and then ln t cancels out. Now this one will be easy to solve, but let us see how. Now items of a will be negative of the integral from 0 to 1 log to the power p minus 1 of 1 by x, and then this is just t to the power minus a. Yeah, so integral will be t to the power minus a plus 1 by minus a plus 1. This is going from 0 to x of dx. Now you can say that I dash of a will just be minus 1 by 1 minus a integral from 0 to 1 log to the power p minus 1 of 1 by x. Now this is just x to the power minus a plus 1. Yes, yes. Minus 0 when x t is 0, it doesn't matter. Now we also have to subtract 1 from here. Minus 1 dx. Yes. So now we have I dash of a is equals to, we have minus 1 by 1 minus a in the integral from 0 to 1 log to the power p minus 1 of 1 by x, and this is x to the power minus a dx. Now to simplify this integral, we will make a of course substitution, which is first of all we will let y is equals to minus log of x. Yes, which is just log of 1 by x actually. Yeah. If you make the substitution, we get I dash of a is equals to minus 1 by 1 minus a. Now this is from infinity to 0, and we know that minus log of x is just y, so y to the power p minus 1, and then x is just e to the power minus y, so this is e to the power minus y times minus a is ay, and then x is e to the power minus y, so e to the power minus y times minus dy. Now the minus sign over here reflects the integral. Yeah, and we get I dash of a is equals to minus 1 by 1 minus a, and then over here this will be now this will be integral from 0 to infinity of y to the power p minus 1 e to the power. Now if I write over here minus a, I will just have sorry, no, sorry, not minus. If I write over here minus y, we will have 1 minus a dy. Now please know that uh, a is actually mm, less than 1. Yeah, because so that this over here, something that's with y, this should be positive. Yeah, so we are keeping a bound for the value of a. Yeah, otherwise, a minus 1 would also be possible. Yeah, but if a is less than 1, 1 minus a is more sensible because this is just this is positive. Yeah, good. Now, radians of a is equals to minus 1 by 1 minus a, and now this is just gamma p by 1 minus a to the power p. Okay, now good. After that, we have radians of a is equals to minus 1 times gamma of p, and then 1 minus a to the power minus 1 minus p. Okay, now integrate both sides with respect to a. I of a is equals to minus gamma of p, and then 1 minus a by minus p by minus p. And also we need to have plus over here. Now we know that I of infinity is just 0. Yes, because if we substitute a equals infinity over here, this goes to 0. So integral goes to 0 and the whole thing goes to 0. I of infinity is 0, we need to find I of 0. Yeah, so let's do that. I of infinity is over here. This is just infinity to the power minus p, so that is just 0 plus c. So 0 equals to 0 plus c. This implies that c equals to 0. Now I of 0 will be minus gamma of p, and then 1 minus 0 to the power minus p by minus p. Is it? So wait a second. I'm missing something over here. And also, since there's a negative sign over here, I also need to put negative sign, negative 1 over here as well. Yes, so 0 to 2 negatives. Also negative 1 over here. Yes. Now this is correct. Now we have I of 0 as minus gamma p by p. And this should be our answer. Let me check. This should be our answer. Minus gamma p by p. Yeah. So this is finally the answer. The answer is quite beautiful. Just that minus of gamma p by p. Yeah. That's quite a beautiful answer. Yeah, and again also write this as minus of p factorial by p square. Yeah, multiply numerator denominator by p. Gamma p times p is just p factorial. Yeah, so this is a pretty cool answer. Minus, and this is a pretty cool answer for this integral. Minus of gamma p by p. Yes. Hope you enjoyed the video. And to recap, we just used a common trick that I've been using for the logarithmic integral function and used Feynman's technique, and it was just a normal integration. Over here it was gamma function, and we got the answer. So that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.